everyone. Thanks for coming. Before we begin, I have a short confession. I've built this presentation myself in PowerPoint. I tried Claude, tried Gemini, tried ChatGPT, and it just didn't work the way I expected. It seemed as if AI doesn't understand my intention. So fortunately, I didn't listen to Sam's advice, and I kept my graphical designer, so it's not a total disaster. But there it is. So I'm Guy Wagner. I'm the founder and chief scientist of a company whose main expertise is understanding, inferring human intention from biological sensors embedded in wearable devices. For the last 12 years, we've been building super sensitive electromyography sensors. We've been building wearables that fuse IMUs, EMGs, and recently also PPGs. And we've been building algorithms that understand human intention, that understand the human hand. And we use all that knowledge into several verticals. We've been doing a health project, like a project that we are doing with rehabilitation of post-stroke patients. We've been doing Industry 4.0 applications for learning how employees in factories use their hands while working. But always our main focus, our main vertical was human-computer interaction, and specifically controlling augmented reality glasses with our neural wristband using micro gestures. Now, this was the first neural wristband in the market ever, and no one really understood why do you need it. You have cameras, you have standard controllers, so why would you need a neural wristband? But things seem to shift, and it seems that the industry starts to follow in these steps, so that's encouraging. And as I say, it seems that AI doesn't really understand human intention. And what I mean is that, for example, if in different situations I will give it the same prompt, I will get the same answer or similar answer. It won't understand my settings or my situation. It doesn't react to me in real time, and it's not proactive. It can't tell me in advance that I need some help. It doesn't read between the lines. And that means that if I want to apply it to robotic or physical AI, it won't be able to read the room. It won't be able to understand the people around it, what is their intention, what is their needs. So that can be even a safety issue. Now, as a company that understands the human intention from biological signals, we are pretty well situated to solve this problem. And that's why we have launched the AI6 Labs. It's our research vehicle for building an alignment layer between human intention and AI agents. So by the end of this presentation, you will understand what is intention and how do we actually communicate it in different scenarios, why agentic AI currently doesn't understand our intention, and how biological signals can fix it. And you will learn how you can, in seconds, build your own intention-based and neural-based experiences. For any organisms to survive in the world, it needs to have some kind of world model that explains how things behave. So, for example, you want to know who is an enemy and who is a friend, what is dangerous, what is safe. Such a model will hold all your past memories, all your experience, actually all that you know. And it can be estimated to hold billions of parameters if we compare it to how we measure the size of neural networks. On the other hand, reality on the environment has this annoying tendency to change all the time and to evolve. And so our poor organism has this constant urge to try and update his model to be like reality or to align them. And this constant urge, this drive to make them similar, to make them align, this urge to close the alignment gap is called intention. So how does it actually work? I have my perception of the world, I have my predictions or my model, I'm comparing them, then if they are not in alignment, I have to either update my prediction or update my perception by acting on the world. For example, I expect to drink this cup of coffee. I bring it up and I find out that it's empty, so I can either ask someone to fill it and change my perception, or I can just understand that it's empty and just go on with the keynote and stop with the jokes. An agent is anything that has such an internal model and has perception and also has this urge to constantly make them align. So an agent is anything with intention. Now, if two agents want to collaborate with each other, they need to share the same ground. They need to share their worldview. So they need to communicate those parameters within their world model. But as we said, these parameters are so many. There are billions of them, so you can only share a tiny portion of them. And what you can share is your observable behavior, body language, hand movements, your face gestures, and also verbal communication. But verbal communication, it takes maximum 30% of all these observable behaviors that we can share. So if two agents want to align, the maximum alignment that they can ever have is limited by the number of parameters that they can share. So if we limit these parameters to text only, we are really limiting, we are really tightening what we can share in terms of intention. Now let's see how it works in real life. So you have two people that want to interact with each other. So they can see each other's parameters as eye contact, facial gestures, hand gestures, body language, tone of voice, hesitation, and also smells. By the way, smells is like EDA, like a skin conductancy sensor. It responds to the fact that we are stressed. So how do we know what to do with these signals? How do our mind use them? How do any of you know that you are hungry? Does anyone feel his stomach growling, maybe? How do you know that you are excited? Maybe you feel butterflies in the belly, or you feel your heart rate accelerating, shaking. How do you know that you've been lied to or mistreated? Some people will say, gut feeling. So all of these are descriptions of body sensations. They are all descriptions of signals that we can actually measure with sensors. We can measure heart rate. We can measure our muscle activity that causes, for example, our feeling of butterflies in the belly. So there are a lot of things that you can look with biological sensors and biological signals, but there are three specific that really intrigue me and that I find really interesting. One of them is gestures themselves. We talk with hands. A lot of people talk with their hands. And it was found by research that this movement of the hands is not random. It is correlated with the words that we say. Its prosody is correlated with when we stop and continue to speak. And there is a reason for that, and that's the same brain area that controls these gestures that we do while speaking is the same one that controls our speech itself. So maybe we can use hand gestures to better understand what people want to say. Oops, sorry. Another one is called cardiac motor synchronization. Our body is a cyclic machine, we have rhythms, our heart rhythm, our movement, and these cycles are usually in synchronization, when we are in flow, when we are focused. But when we are distracted, this synchronization breaks, and we can immediately see that with sensors. And another interesting one is the muscle tone. Muscle tone can, for example, show our readiness. If we are relaxed, it will go down. But if we expect a certain danger or we want to go for a run, it goes up, so our body will be ready to act. Another thing that we can learn for that is our sense of temperature, because when we are cold, our body shivers, and that's muscle tone. So that's another thing that we can learn from it. So if we took all of these signals and trained the network to understand all of the synchronization between them, the patterns they are going, we could learn and we could understand the human body and the others just the same way that our mind understands us, and just the same way that we understand a partner that we collaborate with. We call that the LMM, or the Large Motor Unit Action Potentials model, where motor unit action potentials are these spikes that run on our nervous system. They are actually the code that controls the muscles. And if we build such a model, we could let LLMs understand us better. Now, until now, we've spoken about how we interact with other human beings, but how do we interact with computers? So classically, for the last 50 years or so, it doesn't matter if it was a big PC or a tiny smartwatch or the greatest and latest AR headset. We always use the same paradigm, a control panel that we have to control spatially, a GUI. So we had to navigate to an element and interact with it. So for example, if I want to order a pizza with my PC, I have to break the task into subtasks and then move the cursor of my mouse, select the pizza icon, then select the pizza that I want, then buy it. And all of these steps in the middle, we tend to call them friction, because we would have rather not have them and just think of a pizza and get it. And that's exactly what we expect AI to do for us, AI agents to do for us, to take all the friction away and only leave us with the results. Now, the thing is that alignment is friction. It takes a lot of energy to constantly align our perception and prediction on and on and on and on. It's very tiring. So why not let the AI agent do it for us? So how do we do it? We are acting like a product manager. A product manager writes a detailed PRD, gives it to an engineer, and the engineer just does exactly what's written in the PRD. So every word exactly, but in a way that is totally different from what you wanted. So what you end up with misalignment. You don't get what you wanted. Your model of what you wanted and the world does not align. So what you do? You start to add more text, skills, SoulMD, maybe photos, and still you get maybe closer, but it doesn't really understand you. Some people are going on a totally different strategy. They break their prompts to very small prompts, and they actually micromanaging the agent. But what's the point in that? I prefer to give, why I want an agent? I want someone I can give him the work and go to drink coffee or to the beach. So what will happen if we'll enter in biosignals? And an LMM that could understand from our body our current situation. So it will understand how we currently feel and how we respond to its actions. It can also be proactive because it understands, even before us, what happens in our body. So in such a system, we'll get back the friction but the friction will be managed by the AI agent. And we will only enjoy the alignment. So that's the system that we want to build. And if we have it, how will the world look like? So we will have adaptive AI, which means an AI agent that in different situations will give us different answers and can be proactive and understand us. And we can have adaptive spaces. For example, a house that knows from my muscle tone that I'm currently feeling cold or warm, or knows from my signals that I want to rest or want to focus and change the light settings. One thing that we will not have is passwords and authentication, because the AI agent will know us, and he will constantly monitor us and will know what data we can see, what we can't, and if we want to buy something, it can tell that we really want it because it's something that, that is related to us. One of the most interesting and hottest in the industry is human-robotic interaction. So if a robot with such an AI agent was in your house or in your work environment, it could predict what the people around him will do next. And it will be much safer and much more pleasant because you can cooperate. So now we are going to a bit of selling. So we've built the Mudra Pro. Mudra Pro is our development kit and research kit, data collection tool. It has 3 EMG sensors, IMU, and also a PPG. And it will allow you to build such a model that can understand human intention. I'm also mentioning the Ultimate. The Ultimate is currently still under development, but it will have 8 channels of EMG and a very strong microcontroller that will also allow you to run algorithms on the band itself. What's next? You can come to our booth and try the Mudra Link, and you can also buy it online and try neural-based and intention-based control. You can try in our room 201A on the 2nd floor, and you can try the Mudra Pro. And you can try to build in seconds any intentional-based, neural-based application with our new Mudra Studio platform, a vibe coding platform. You just write a prompt. In our case, it understands you, and you get the result that you wanted. And we would be happy to partner with you if you have a special project that you want to do. We have a lot of knowledge in the field, and we will be happy to share it with everyone. And one last thing before we go. We are releasing a white paper that goes very deep into what is intention and how we can use it to train AI, how can we use it with robotic or physical AI, and where augmented reality gets into the picture. So you can scan the barcode and download the white paper. And of course, if you have any questions, please feel free to contact me. Have a nice trip home and enjoy the rest of the show.